If man were to stand to attention before certain phenomena that govern life and the action of the vegetal and animal worlds, he would literally remain speechless. In the middle of the 19th century, an inventive orthopedic doctor, Dr. Pravas, invented the syringe. Dipping a needle in the flesh to administer medicine was considered to be a peak achievement in his day. However, nature was first. If we study snakes, we will note that on their head and in their mouth, they feature an amazing syringe device. It is made up of the gland that contains the poison, the pipeline that transports it, and of a set of special teeth in the upper jaw. These teeth are hollow, perforated inside, and terminate in a sharp tip. When the snake bites its prey, the muscles around the gland contract, forcing the poison to exit, and, from the tip of a special tooth, the liquid pours into the foreign body. Put otherwise, a totally surgical intervention. In 1800, the Italian physicist Alexander Volta brought to light a unique invention. He invented the electrical battery, which even took his name and was called the voltaic cell. This invention was characterized as the greatest scientific achievement the world had known. However, here too, nature was first. At the bottom of the sea, at a depth greater than 500 meters, where absolute darkness reigns, there are fish with real electricity. That is, fish with an electrical current produced in independent generators in their bodies. We can easily name them electrical energy production factories. Every one of those fish is a perfect electrical appliance, whose only missing elements are a clock and a switch. The world believes that Joseph Montgolfier is the first person in the world who in 1777 managed to devise a parachute. However, the world is wrong. Before Montgolfier, there was the radish. If we carefully observe the seeds of the radish when they fly in the air in order to be scattered in nature, they are all tied to a delicate but hardy piece of fluff, which is a microscopic parachute. Exactly the same parachute is tied to the shoulders of the seeds of the poplar tree and the plane tree, only that instead of fluff, they are carried by silken threads. We live in the space age. Thousands of scientists in the entire world continually invent new apparatuses, as much for the exploration of outer space as for man's colonization of another planet. Many of the instruments that the scientific community uses today are a faithful imitation of amazing organs of some snake or insect. Certain snakes, like the Orphis trigonocephalos of America, commonly called the rattlesnake, have on a small cavity between their eyes an astonishing heat detector, a thermometer of exceptional delicacy and sensitivity. If something passes near the snake that presents even the slightest difference in temperature from that of the environment, even a difference of 1,000th of a degree Celsius, the snake immediately detects it. And if the passing animal belongs to an edible species, the snake strikes instantaneously and devours it. On the basis of this serpentine apparatus, American scientists invented a significant thermometric instrument, and equipped with this, for the first time, The satellite, MEDA, had as its mission the precise recording of the temperature of atmospheric levels. A few years ago, the international press wrote, "Mars will be explored by the eye of a frog. An apparatus has been invented that imitates its properties." The frog immediately perceives the existence of microorganisms. When neurophysiologic scientists carefully studied the frog's eye, they noted two properties. First, it sees only what is near and is of immediate concern to it. And secondly, at critical moments, it automatically puts parts of its body into motion without any energy from its brain intervening. Put succinctly, the frog has a second brain in its eye. When scientists planned the exploration of the planet Mars with the Viking, they required an apparatus that would be placed in the space vehicle to provide information about microscopic forms of life that could possibly exist on the red planet. The apparatus they devised was an instrument that operated like the frog's eye. Another more recent newspaper publication writes, "The fly's eye in space." Astronauts photograph details about the stars with a new camera. When a telescope photographs a star, the photographs present a confused image owing to the refraction of light. The atmosphere around the visual angle of the telescope refracts the light that enters into the reflector. If, however, the reflector is divided among many smaller lenses in accordance with the polyhedral eye of the fly, then 100 to 500 images are recorded for each photograph, and in the end, the different information on each photograph is assembled, and we have a total, clear representation of the location in space that we photographed. In this way, distortions that Earth's atmosphere creates are neutralized. Visual astronomy has a debt of gratitude to that bothersome insect called the fly. A little before the Second World War was declared, the distinguished British scientist Sir Robert Watson Watt invented a most significant apparatus, which proved to be very useful in the war that followed. This apparatus possessed the ability to detect enemy ships, or submarines, or airplanes, in darkness or in light, in rain or dry weather. The apparatus was our well-known radar. Radar is formed by a transmitter and a receiver. It is, in other words, a complete radio station. The transmitter produces waves, which by means of a metal antenna are sent in a given direction. If, in their transmission, they meet with an obstacle, they are reflected and returned to the receiver. The user sees the reflection of the wave on a special television screen and takes the appropriate measures. In times of peace, the radar is the guardian angel for ships that are in danger of crashing into other ships